There's this concept called a leading zero. I've seen this happen. I've heard of this happening. A child once had a severe salt wasting nephropathy. Salt as in sodium chloride, wasting as in the kidneys, losing sodium chloride, nephrokidneypathy as in problem pathology. So a child had a problem with their kidneys that caused them to lose salt. So they ordered the child to have a 3% sodium chloride solution. 3% sodium chloride is very concentrated. It's going to be very rare for you to ever see anyone on a 3% sodium chloride solution. Well, later the child did really well, and they wanted to switch to 0.9% sodium chloride, and we call that normal saline. There's a reason normal saline is called normal, because it's like normal concentration of salt physiologically. And so the best way to write for 0.9% sodium chloride is just say normal saline. It's not hard to spell, normal saline. But they did not write for 0.9% sodium chloride. They did not write for normal saline. They wrote for 0.9%. And the decimal point was not seen by the pharmacist. So the pharmacy prepared a 9% sodium chloride solution. I've never seen a 9% sodium chloride solution prepared for anyone except in this situation that is 10 times more concentrated than normal. And so because they did not write the zero in front of the decimal point was not seen, and the pharmacy prepared 10 times the concentration of sodium chloride that was ordered. This turned out to be a fatal error. I've seen this happen on more than one occasion. I think I've seen this happen about 3 times now. Not necessarily normal saline, but a leading zero with the decimal point not seen, resulting in a medical error of 10 times the dosage because of a missing leading zero. 0.9 and 0.9 are exactly the same thing. There's no difference between those things in mathematical terms. However, the difference between 0.9 and 0.9 in a clinical setting, I can assure you, is the difference between life and death.